there's a question from memes here. If atoms of space act like a superfluid, would that mean there are vortices that arise if the universe is rotating? Oh boy. There are definitely the analog of vortices, which can arise in the kind of underlying structure of this kind of giant network that represents the structure of space. There absolutely can be things like vortices. In fact, particles like electrons may very well be the analog, not quite as direct as just things circulating around like a vortex, but the basic analog of a vortex in the structure of this network. I'll give you a bit of an analogy. We don't know exactly how this works, but if you have a network, just a bunch of points connected together to make a graph in the mathematical sense, you've just got all these points, and let's say you connect them with pieces of string, and then you say, can I lay out this whole sort of tangled thing with, places where the pieces of string are connected together? Can I lay that out so that it is planar, so that there are no pieces of string ever cross over, that they don't ever have to cross over? You might have one arrangement where there are lots of pieces of string crossing over, but the question is there a way with the connectivity of the pieces of string to lay it out so that the thing is planar, so there are no pieces of string crossing over? So that's a mathematical question, the planarity of a graph. And there's a theorem in graph theory that says there's a condition, there's a very definite condition you can state for whether you'll ever be able to set up the pieces of string so that they're purely planar. And the condition is that certain subgraphs, certain particular local arrangements of pieces of string, there have to be two kinds of subgraphs that are missing. They're called K5 and K33. They're just particular arrangements of sort of pieces of string, arrangements of the graph, and if neither of those local arrangements is present, then you can lay things out in just a nice planar way. But if you have one of those sort of non-planarities present, you can't get rid of it. If you rearrange the string and you even change the structure of the graph, but always preserving planarity, you can't get rid of that thing. And that's kind of like the fact that you can't get rid of that, the piece of string that was wound around the pencil or the vortex in the fluid, same kind of idea. And it's that kind of local stability that we think is associated with the existence of things like electrons, which are essentially, in our models of the universe, sort of local regions of space. There's a strange analogy, which we don't understand very well yet. There's a strange analogy between black holes and particles like electrons. It's probably more than an analogy. They're probably really very, very similar kinds of things. A black hole is a region of space where the structure of space is such that, for example, there are things can get into that region but cannot get out of that region. It has an event horizon, for example. It's sort of a place where the structure of space has become very kind of very condensed, and there's this kind of outer boundary which hides everything inside that region. Well, the suspicion is that electrons are very similar to really tiny black holes, and that they too can potentially have, they have a structure just like black holes from the outside. All you can see is, oh, that's a black hole of a certain mass that's spinning at a certain rate. The fact that, oh, it was a collapsed star inside and it had a whole civilization and they were, they've got all kinds of things going on in there, doesn't matter. You can't see that from outside a black hole. And so similarly for an electron, one of the things that's always surprising about electrons is that it seems like every electron in the universe is the same. They all have, it's not the case that it's electron number one, electron number two, and they're all a bit different. Well, that can happen if sort of inside the electron, there can be all kinds of things going on, but it has kind of an outer boundary that prevents one from noticing what's going on inside. And that would be the direct analog of a black hole, although at a very different scale. And that's kind of the suspicion about how that works. And the suspicion is that both of those things, we know for black holes this is the case, but they're kind of versions of kind of like a vortex in space-time. It's not actually a vortex, it's a different topological structure, but it's the same kind of idea.